Hello, everyone. Um, Welcome. We're at the top of the hour. And if you're wanting to join us in a conversation about mixtures and safer alternatives, you're at the right place. So thank you for joining. I'm Molly Jacobs. We're just going to get started. We're expecting about doubling the number of people that we have with us right now. But we'll go through some introductions and we'll get into the heart of the matter while everybody has had a chance to join us. As I just mentioned, I'm Molly Jacobs. I am our Director of Applied Research at the University of Massachusetts Lowell in a research institute called the Sustainable Chemistry Catalyst. And I'm also very actively involved in our program committee for the Association for the Advancement of Alternatives Assessment, which is helping to kind of sponsor, if you will, this workshop. This is a three-part series, and you'll hear a little bit more about that, but we're all experiencing the first part of the series today, understanding the current state of hazard assessment approaches being used in product level assessments. And the premise for this workshop is one on helping to evolve our methods and practice for alternatives assessment. So as I think most of you know that are joining us now, alternatives assessment is a process to support the informed substitution of hazardous chemicals. In the National Academy, the National Research Council guide that you see shown here, it's actually defined as a process for identifying, comparing, and selecting safer alternatives to chemicals of concern on the basis of their hazards, performance, and economic viability. But the current methods that we have, kind of the guidance documents that we have to support alternatives assessments, were designed to evaluate substitutes to a chemical of concern in a given product, essentially thinking that we can replace that chemical with a safer alternative and keep on keeping on. It was never really envisioned, even though we know we're working at substitutions within products, within processes, of trying to think at that whole product level, what the assessment has to look like, considering that this is a complicated mixture of chemicals in a product. And rarely do we see in practice that we actually have drop-in substitutes available. I mean, an example of this we're going to hear in one of our formative presentations, but is the example of aqueous film-forming foams that contain PFAS. We're seeing through the Department of Defense a number of new formulations coming online, but these are entirely new products. So the question is the product safer than the incumbent? Not necessarily is the chemical of concern that prompted the whole issue, safer than not. So what we're interested in pursuing here today is, how do we evolve our alternatives assessment practice, evolving our hazard assessment methods, because we are beginning to address questions at the product level, and we have several examples of that. And the question is really one of, how do we, what can we learn about the methods that are being used? There's a variety of methods being used. And so what can we glean from them in terms of, best practices to support informed substitution efforts going forward? What are current limitations? And in thinking this through, what are the data and tools that are currently available to us or not to support product level assessments and substitutions decisions? And so, this is a lot here is wrapped up in a lot of thinking that has been done for, a couple decades now on mixtures. The difference here, though, is the substitution context. This is not research for research's sake. We have to do these evaluations in order to make decisions. We have to have the resources, the capacity, and considering the time needs to make a decision about what's a safer product and to move forward and to commercialize that. So it's different than, per se, a lot of the conversations that perhaps many of you have been involved in with regard to mixtures. But we want to apply that context to this question of how do we better inform substitution decisions at the product level. So as I mentioned at the start, this is a three-part series of a workshop. And the primary goal for today is to understand the current state of hazard assessment approaches that are being used in product level alternatives assessments. And to do that, we have, we're going to launch the discussion with 3 formative presentations and spend our second hour with all of you discussing what seems to work, what needs to evolve, and where do we go forward together. And so it's really important, especially in our second hour, we've organized this as a workshop. So we're half of it is to give you some food for thought, and half of it is to really engage all of you in discussion. And so, please participate with us because your input is really important. We're going to have a second workshop on October 6th that will also be virtual. And there we want to kind of look at other aligned fields, look to that research space on mixtures and how methods and tools that are being used in better understanding the health effects of mixtures can be transferable to the evaluation and the substitution decision context for products and alternatives assessment processes. So if you haven't registered for that, please do. You could do so at the saferalternatives.org website. And we're going to finish this all off in person on the October 25th at the International Symposium of Alternatives Assessment. We'll summarize kind of insights and conclusions from these first 2 events and collectively work with the community of practice on alternatives assessment to identify what the needs are going forward to better to support best practices, to fill in gaps in knowledge, to advance consistency in how we address product level assessments going forward. So before we begin, I want to thank our planning committee for this workshop. This workshop has been in the making through really stimulating discussions that the Association for Advancement on Alternatives has been having with the National Institute of Environmental Health Sciences, specifically the Division of Translational Toxicology, and specifically its Safe and Sustainable Alternatives Program. And so you can see all of the colleagues that were involved in kind of creating this workshop together. So thank you for committee for your time meeting together and talking this through. And we hope that our work in planning this is felt and experienced by all of you participating. So we are using Zoom meeting. We're not using Zoom webinar because we want you all to participate. So there's, you all know Zoom, you all know the etiquette in general, but do keep your lines muted and your videos off unless you're, speaking or joining us. It is because rather than having Hollywood squares all over your screen, it is best to use the speaker view in Zoom so that you just see a speaker at a time and a slide deck if it's being shown. And again, please engage with us during the second hour of this workshop. It'll be helpful if you raise your hand, and then please feel free to unmute yourself, turn on your video. We really want to add more voices to this discussion. If you're nervous about that, or if you're in a place where you're uncomfortable to do so, please use the chat. And do know that this workshop is being recorded and will be posted on the alternatives, the Association for the Advancement of Alternatives website, which is saferalternatives.org. All right, so before we start, I want to launch a couple of polls just to better understand who is joining us here today. So with that, if you all could let us know what sector best represents you. Kind of want to understand who's with us today. All right. I will publish this. So it looks like we have, I mean, a good distribution of participants, mostly from government and private consulting, but definitely academia, as well as nonprofits and various folks from industry as well. So again, thank you all for taking the time to participate with us today. One more poll. Did you all see the results of that, by the way? Okay. Let me do one more. And that is really one of just trying to better understand, your experience with this topic. So yeah, we're interested to know, what's your familiarity with this topic of, hazard assessments, and especially that for products. Which of these categories best describes how you're currently engaged in this topic, especially as regard to kind of formulated chemical mixtures and their evaluations. And with that, I'm going to close the poll. And it looks like the majority of you are actually actively involved in conducting these types of assessments. And some of you are involved in, just staying abreast of the literature on this, or conducting research in the space. And many of you are also just coming to this workshop out of general interest. So we will make sure that we've asked our formative presenters to, speak to a general audience, although it sounds like the technical base that many of you are coming to this workshop with is quite robust. So, so thank you for that. All right. Well, with that, I am going to keep moving us forward. And just again, through all this introduction, I've given you a layout of what to expect. So for our first hour, we're going to have 3 formative presentations that provide differences, but similarities in many ways of current practices of evaluating the hazard of formulated chemical products. So each presenter has been asked to speak for about 15 minutes. And we had time after each for just clarifying questions. If something wasn't clear to you, if you have a question about a particular criteria or methodology or something that was presented, please feel free to raise your hand and we'll go through some of those questions. I will limit them to keep us moving. Please save your comments, your reflections, your insights about what you're hearing for our group discussion. So we'll just keep clarifying questions to a minimum after each presentation. And then we'll have our second hour together, where I'm really hoping that we'll have a robust conversation about some of the merits and challenges that have been described in the approaches being described, as well as entering into the conversation other approaches that are being used. So do engage with us in full during that second hour. And with that, my colleague at A4, Kathy Rudisell, is going to help facilitate the discussion through the chat. I'm a horrible multitasker, so I'll help our conversation going, and but you're going to hear another voice and perhaps see Kathy as well, and she'll help kind of facilitate what we're seeing in the chat. And if there's something that seems interesting or illuminating, again, we might call you out to further explain or describe some of the thoughts that you might have written down. So with that, I'm going to introduce our speakers. And today we have with us Lauren Duffy. She's at the Safer Choice program within EPA, is going to describe kind of the criteria and the process used to evaluate the hazards of products that are given the Safer Choice certification under EPA. We also have with us Gill Pagiluca, and Gill actually trains people on the GHS Mixtures classification rule, and is associated with the Denehurst chemical safety group out of the UK. And our final speaker to give us kind of some formative thoughts of how to think about this all together is Andrew East. And Andrew is with the U.S. Department of Defense and their Defense Center's Public Health Group. And Andrew's going to talk about an assessment that was done on firefighting foams, evaluating the PFAS-free alternatives. So with that, I'm going to pull down my slide deck and ask Lauren to put up hers. And Lauren, you have the floor.
All right, thank you, Molly. I'm thrilled to be here with all of you today and looking forward to the discussion coming up. Apologies, give me 1 second. Okay, so EPA created the Safer Choice program as a voluntary partnership program to help consumers and commercial buyers identify and select products with safer chemical ingredients without sacrificing quality or performance. The program is grounded in EPA experience evaluating the human health and environmental characteristics of chemicals. And the label is important because it facilitates rapid decision-making by consumers in the marketplace. And as a result, it's incentivizing safer chemistry in the marketplace. To date, the program has about 2,000 certified products, 400 of which carry our fragrance-free label. And so the Safer Choice recognition is based on using the safest possible ingredients to make high-performing products. The program's requirements are outlined in the Safer Choice standard. And at a high level, Safer Choice reviews each ingredient within a product, and I'll get more into this later, and also considers whole product characteristics, things like VOC, content, and pH level, as well as we have some packaging requirements. And as part of our partnership compliance, Safer Choice verifies the authorized formulas by completing yearly audits during the partnership agreement. And we require our partners to renew their products every 3 years, just so we can verify that they're using the same formulation or review any new components to their formulations. And so I think it's easiest to think about our standards sort of at 3 different levels. At the company level, we have a partnership agreement with them and we perform these yearly audits. And then at the product level, we are considering things such as performance. While our goal is safer chemistry, if a product doesn't perform, consumers aren't going to buy it. And there's really not as much incentive to formulate these safer products. So performance is certainly an important factor. We're also looking at product level things such as pH, as I mentioned earlier, or very obvious synergistic effects, things like having limonene and with oxidizers. That's a known sort of chemical reaction that we want to avoid. And as I mentioned, we also have some packaging requirements. But for the bulk of this talk, I'll be discussing our chemical review process. And so within our program, we evaluate every single chemical that is in a product. There is no de minimis. So we are looking at impurities, we're looking at residuals, truly everything is considered. And we require that our partners disclose all ingredients and we go up the supply chain to ensure that we have a thorough understanding of what is included in every product. And we take this to a level that goes beyond just seeing if it's on a restricted list. The Safer Choice program uses an approach where we acknowledge that each ingredient in a formulation has a role to play. So if you think about a surfactant that in a cleaning product is reducing surface tension, or a solvent that's dissolving or suspending materials, we recognize that each of these ingredient types has a specific function and it's essential for the product to perform. So within these functional classes, as we call them, many ingredients share similar toxicological and environmental fate characteristics. And so what we found in developing the program is there are challenges in identifying what's on the safer end of the spectrum, but a way that we're able to get around that is by looking within each functional class. And so the Safer Choice program focuses the review of the formulation on the key environmental and human health characteristics of concern within a given functional class. This approach allows formulators to use ingredients with the lowest hazard in their functional class while still formulating high-performing products. And we use thresholds that align with both GHS and EPA's new chemical program or division. Chemicals that are candidates for use in certified products go beyond being on, we're going beyond being on restricted lists. So none of these are on restricted lists, and we use this as a way to identify what is in fact safer. So you'll see this list of different endpoints, and functional classes focus on certain endpoints as I measured, but we have thresholds associated with each one of these endpoints. And I'll give you two examples. So for acute mammalian toxicity, these are our thresholds that we are reviewing available data against. And we are looking to see if the available data is above these published thresholds. And I'll note that this aligns with the GHS thresholds. Similarly, when we're thinking about environmental toxicity and fate, we take an approach that is looking into, that accounts for both aquatic toxicity as well as persistence. So depending on the aquatic toxicity value, we have requirements for persistence. So something that is more toxic, in order for it to be acceptable, it needs to degrade faster than something that is less aquatically toxic, for example. And I know there's a lot on this slide, but just trying to give you a sense of our different thresholds that we use. And so as I mentioned, we're going beyond lists. We're comparing data to these thresholds that I discussed. And we do that by using several different data sources. Obviously, it's great to have experimental data on the chemical that is actually in the product. But when you're dealing with the safer end of the spectrum, that's not always possible. There's not a ton of incentive to develop data for these safer chemicals. A lot of the focus is on more problematic chemicals, which typically makes sense. So a way we circumvent that is we're looking for suitable analogs, and where they are available and have data, we use read across for the chemical that we're evaluating. We also are able to use many of the models that both EPA has developed, as well as several other programs. And then we're also always open to new approach methodologies. One benefit of this program being within EPA is we have access to a lot of data that's available through the new chemicals program and other various programs. So what we found is industry partners are used to sharing information with EPA. So we don't typically run into issues receiving this information if it is available. And so once we've evaluated chemicals, we put them on the safer chemical ingredients list, which is a positive list of more than 1,000 chemicals that meet our criteria. And we found that many of our stakeholders use this list in various ways. So chemical manufacturers highlight their sustainable offerings by having their chemicals listed on Gill or in another program called Clean Ingredients. Our product manufacturers often look to the list to help when they are trying to reformulate or develop safer choice certified products. And then a lot of retailers actually use the list as a basis for their sustainability programs. Another thing I'll note is it's a positive list. And so, I think there are a lot of resources out there that focus on chemicals of concern or chemicals that you want to avoid having in your product, but this is unique in that it's actually showing you what you could use to make your product contain safer ingredients. And the skill list is organized by functional use class. So again, as I mentioned earlier, we are comparing everything to similar chemistries because they have similar functions typically, and so they are listed by their functional use. And then what we do to sort of communicate to the public our level of confidence for each chemical is we designate various color codes. So a chemical that is listed on Gill as a green circle is one that we've identified to be low hazard based on experimental or model data. And we have a high level of confidence associated with this. A chemical that has what we call a green half circle on Gill is something that we expect to be of low hazard based on the data we have available, but additional data would strengthen our confidence in this chemical status. So it is possible for a chemical to get listed on Gill as a green half circle, but then if more data is developed, or in that product re-review phase, if we identify new information, sometimes it can get promoted to a full green circle. And then additionally, we have yellow triangle chemicals. So these are chemicals that meet our criteria for their functional ingredient classes, but they may have some hazard profile issues associated with them. A common example is preservatives. These are essential for products to perform, but they are by nature a little bit toxic in order for them to perform. So many of these are yellow triangles on our Gill list. And so in thinking about our approach to chemical assessment, as with anything, there are some merits and some challenges. So I think many stakeholders value having the safer choice or safer chemical ingredients list as a resource so that they can identify what is in fact safer. I think there are several other resources that help people identify what to avoid, but a lot of times that's not always helpful for them if they are looking to reformulate. They want to know what they could in fact use. And I think a variety of stakeholders really appreciate the focus on the positive end of the spectrum. Additionally, we pride ourselves in the harmonization with internationally accepted standards and thresholds such as the GHS criteria. With this, though, as we're thinking about strengthening our criteria for certain functional classes, we like to evaluate the functional class as a whole and the data associated with each chemical to determine where we could distinguish safer chemistries. And a challenge I would say with this is that it can be really challenging for things like surfactants or polymers that have very variable compositions, even within a given CAS number. And with a range of compositions or structures, it's likely to have very different toxicological profiles. And so when it comes to updating the criteria, it can be really challenging how to account for these variable chemicals. As I mentioned also, in terms of another challenge we run into, when we're working on the safer chemistry side of things, many chemicals don't have a ton of data because they're not a priority for testing, or in an academic sense, sometimes publishing a paper on no effects is not likely to get accepted. And so when companies do have data, or they choose to develop data for an endpoint and it doesn't end up meeting our criteria, they can sometimes, have this feeling of being penalized for actually having data. Another benefit to our approach is using the color codes, where we can display our confidence in the Gill listing based on, the green, the full green, the half green, or the yellow triangle. I think that's an easy, clear-cut way for folks to understand where it falls within its functional class. But with that, a challenge we run into is each functional class may have different distinguishing endpoints of concern. So a chemical that is considered safer in one functional class, if that chemical could also function in a different way, it may not be in fact what is safer in that other functional class. So those are some things that we run into in, fulfilling this criteria and also the standard. And so with that, I'm happy to take any clarifying questions.
Great. Any questions for Lauren? And thank you so much, Lauren. Great presentation. Great opening to this workshop. If you want to raise your hand, I can call on you. You could also just post a question into the chat if you have something for Lauren. Well, Lauren, you stumped everyone up. We'll just wait one more second. All right, we do have one question. How quickly do you assess chemicals that have an updated GHS rating?
Interesting. So we independently review every chemical, and we shoot to do it every 3 years as our resources allow. So while our thresholds are aligned with GHS criteria, we actually gathered the data for ourselves and evaluate it against our threshold. So we're not necessarily alerted to an update on a GHS listing or classification. We are internally making the decision for each chemical.
Great, thank you. Any last question for Lauren before we move on to our next formative talk? All right. Well, thank you, Lauren. And let's have Gill come up next. Gill, if you want to load your slides, and we'll pass the baton on to you. Oh, we don't hear you. You want to unmute yourself?
Okay, you can you all see the slides okay?
Looks great, thank you.
Right, thank you. Okay, sorry, I got there. Okay, so I'm going to just give a quick overview of the GHS mixture classification rules. We're not going to go into any of the detail of classification because that's a 3-day training course, but just want to try and highlight perhaps some of the a quick overview of the methods and some of the kind of pros and cons of using GHS and how it can be used to classify mixtures and try and select safer ingredients. Okay, so GHS then, this is the globally harmonized system of classification and labeling of chemicals, which was developed as part of kind of one of the kind of like through the World Summits on Sustainability to try and provide a sort of level playing field, both in terms of facilitating trade, but also in terms of worker protection around the world. And it's now been implemented in over 70 countries around the world for some or all of chemical classification regulations, and depending on where you are in the world, it may apply to industrial chemicals, professional chemicals, household consumer chemicals. Typically, it doesn't cover things like cosmetics, toiletries, medicines, food additives, which tend to have their own sector-specific regulations, but it tends to pick up everything else that's not covered by a specific sector regulation. The GHS is primarily involved in identifying the hazards of the substance and mixture. It is based on intrinsic hazard, doesn't take risk into account. It's a system that's totally based on the identification of intrinsic hazards. And then once those intrinsic hazards have been identified, communicating those hazards to workers, customers, consumers via things like labels and safety data sheets. So there are 3 main approaches that are used for mixture assessment in the GHS. The first method is classification from raw test data. And obviously, if you have tested your mixture, then that's going to give you the best and most accurate view of the hazards of your material. However, mixtures are not normally tested for health and environmental hazards due to animal welfare considerations. And so although we have that provision in the GHS, it's not used very much. Next in the hierarchy for classification of mixtures is read across from similar mixtures, and this is called the bridging principles in the GHS. But basically, it's a sort of common sense approach using read across to predict the potential hazards of an untested mixture when you have data from a similar tested mixture. And as long as you meet the specified conditions for the use of that bridging principle, you can use it to predict the classification of your new mixture. But since we don't test very many mixtures, the bridging principles don't get used very often either. So, you know, we're not often using those. The majority of mixtures tend to be classified using calculation-based approaches. And these are set out in the GHS. There are different approaches for different types of hazards. But the advantage of the calculation-based method is that we don't need to test our mixtures. Instead, we can use data that's been generated for the substances that are in our mixture to predict the overall hazards for that mixture. Calculation-based approaches are used for health and environmental hazards. They're not used particularly for physical hazards, as generally those need to be tested. It's not generally possible to predict the physical hazards of a mixture. But for health and environmental hazards, it provides a way to easily generate a classification for your mixture. So, as I said, there's a couple of different ways that the calculation-based approach can work. We have what are called additive approaches, where we are basically assuming that the contribution made by each ingredient to the overall hazard of the mixture is proportional to its concentration, so how much of it there is in the mixture, and it also proportional to its potency, so how strong an effect it's having. So we use those additive approaches then, particularly for hazards like acute toxicity and for skin corrosion and irritation and eye damage and irritation. And for aquatic hazards, so short-term and chronic aquatic toxicity. The other approach that we have within the GHS is the sort of non-additive approach or threshold approach, where we are identifying ingredients in our mixtures that might have a particular effect that is specific to that substance. So these things, they're not generally additive. We are looking to see whether there is enough of this substance in our mixture to meet the threshold, and if it is, then the mixture is classified as hazardous. If there isn't enough to meet that threshold, then the mixture is not classified for that effect. And if you have multiple ingredients within your mixture that have the same hazard in that case, so you had 2 or 3 different reproductive toxins, each one gets compared to the threshold. We're not really looking at any synergistic or antagonistic effects here. Each one's just treated individually to see whether it meets the threshold or not. And so this threshold approach then is used for things like sensitizers, so-called CMRs, mutagens, carcinogens, reproductive toxins, for target organ toxicity. And perhaps more controversially now, in Europe, the EU has just added to their implementation of the GHS criteria for mixtures containing endocrine disruptors and persistent chemicals. So these are not yet part of the GHS criteria. The EU are pushing for them to be added into the GHS. But controversially, they have been added to the EU's version of the GHS, which is called the CLP, Classification, Labelling and Packaging Regulation. And so those will now be considered in Europe for mixtures as well. So calculation-based approaches, then I said they are the most commonly used method for classification of mixtures. The predicted classifications are fairly conservative. So in the setting of the thresholds that are used for classifying mixtures, a fairly conservative approach was taken, particularly for things like corrosion and irritation. The thresholds are quite low to trigger classification. The classification, the methods are easily translated into rules that can be incorporated into software, which has a big advantage for many companies. It allows them to process lots of mixtures fairly quickly and without necessarily having to have a huge amount of expertise. And indeed, many companies out there who are formulating mixtures, in fact, probably the majority of companies out there formulating mixtures are probably SMEs. They don't tend to have any toxicologists or ecotoxicologists on their staff. Many of them don't even undergo any training on the actual GHS classification rules themselves. They may buy into a software package, and it's a bit of a black box where they're sort of, putting in some formulations and out pops a classification at the end. So it allows them to do that without a great deal of expertise and knowledge, and to do that fairly quickly and easily. There are some sort of pros and cons to that, though, which I'll talk about in a second. But you can see here, we've got a screenshot from a software package that allows you to do these kind of classifications. And you can see we can very easily add in different ingredients. We can change the percentage of ingredients in our mixture. And we can very easily play about with the formulation in order to try and avoid our mixture from having certain hazard classifications. We don't want to put sort of scary labels on the On the packaging for our consumers, we want to try and have safer mixtures, and so we can very easily play with the formulations using software like this in order to try and formulate our products to be non-hazardous according to the GHS. The software usually comes with a database of ingredients as well. So the software suppliers will often draw databases of classifications from various sources, such as in the EU, Annex 6 of the CLP regulation, or perhaps some of the REACH registration data, and then other countries, particularly in Southeast Asia as well. Many of them have lists of either mandatory or voluntary classifications, and so they may be drawn into the databases and can be used as the basis for classifications. Some of the con side of the software, as I said, is that often those who are using the software may not have a lot of knowledge about the rules for classification, and that can often lead to an incorrect classification if they don't understand some of the assumptions that are being made in the software. The other big problem, I think, with these kind of software solutions is, as I say, there's often a database of ingredients in there, and those ingredient classifications, how good are they? How reliable are they? They're not always questioned. We just had a question on Lauren's presentation a minute ago, asking how often EPA are upgrading if the classification, the information, if the GHS criteria change. The same problem applies to things like, Annex 6 from CLP, or, the Japan night classifications and so on. Any of these kind of lists of classifications is really out of date as soon as it's published. They're not systematically reviewed whenever the classification criteria changes, or if new data become available for a chemical. So, there isn't a consistent approach to, continually keeping these lists up to date with the latest scientific information. Other problems with the software, using software, so say, so ingredient classifications, there are these databases there, but of course, those databases of classifications maybe only cover a few thousand ingredients, and there are, many tens of thousands more chemicals that may be being formulated into different products. So where do you find the correct classifications to go in? Because if you're doing a calculation, as with any calculation, if the data that you put into your calculation is not correct, then you're not going to get a correct answer out of it at the end of the day. So we need to have high quality ingredient classifications going into our software. People are normally told to rely on the classifications that come from the suppliers of the raw materials. The problem that you often find is that maybe a company buys the same raw material from 2 or 3 different suppliers, and they will have 2 or 3 different classifications for that raw material depending on who they buy it from. Now, in some cases that may be justified. There may be a different impurity profile, or if it's something like a powder, perhaps different particle sizes may be affecting the classification. But often it's just simply that the suppliers may be working from different data, different versions of the GHS, and so on, and so they end up with different classifications. And how is the user expected to know which is the correct one to use? We have different classifications in different jurisdictions. So the GHS, although it's called the globally harmonized system and is implemented in 70 countries, there are many different implementations of the GHS. It's not been implemented the same in every country. So some countries have chosen to only implement certain parts of it. There are different thresholds that can be used for classification of mixtures. And then, of course, there are different versions of the GHS. It gets updated every 2 years. So if people are working from different versions using different criteria, they are going to end up with different classifications. And I mentioned the new hazards of concern, so things like endocrine disruptors and persistent chemicals, not yet included in the GHS. Other areas, global warming chemicals is an area that the GHS are working on at the moment. So again, so as different new hazards are identified, they may be adopted differently in different countries. So again, we end up with kind of like a not very global and not very harmonized system, unfortunately. Another big problem that I often come across with the GHS is identifying the relevant ingredients to include in the software. So it's quite common for the supplier or for the user to just go down to the factory, get the mixing recipe, and incorporate that into the software. But that's not necessarily what's always in there. If you've got any kind of reactions going on, particularly neutralizations and so on, then you will not get the correct classification. As a very simple example, if you put into a software that you've got 500 mils of hydrochloric acid and 500 mils of sodium hydroxide, the software will tell you I've got a corrosive ingredient, another corrosive ingredient, my mixture must be corrosive. But actually, hopefully, we all know that those are going to react together and we're going to end up with a solution of sodium chloride, which is not hazardous. So we need to make sure that what we're putting in terms of formulation is accurate. And again, that's often a problem. I think one of the other big problems with the GHS is cut-off value. So there are thresholds there which you're allowed to ignore ingredients if they are present below a certain threshold. It's considered that if they're below that threshold, then they're not going to contribute significantly to the overall hazard of the mixture. But people will try and manipulate the system. So if you perhaps have corrosive ingredients, the threshold there is normally 1% to include them in the system. But you may have, they may put 3 or 4 different corrosive ingredients in there at 0.9%, and the system will ignore them all, and you won't have any kind of classification for corrosion or irritancy because they're all below that threshold. Where actually, if you apply a bit of scientific knowledge and judgment, you think, well, probably that actually that's not going to be correct, and there probably should be some hazard warning on the label. Other problems. Many ingredients are mixtures themselves that go into a mixture, and disclosure of the ingredients in a mixture is a problem. You're supposed to identify hazardous components in the safety data sheet, but they're not always identified. So some countries have very strict trade secret laws that allow people to not declare. Other countries have much more or require much more disclosure, and so it can be easier to identify hazardous components. But so it depends very much on where the raw material is coming from, what level of disclosure there is on the safety data sheet. And then finally, GHS, as I mentioned, doesn't really consider any interaction between components, whether things are reacting synergistically or antagonistically. So just to demonstrate that, so we have a couple of papers that were published a few years ago now. One looking at plant protection products and one looking at detergent and cleaning products, and comparing how well the GHS rules, or in this case CLP, which is the EU implementation of GHS, predicted the hazards of the mixtures using the standard rules versus test data for the material. And what they found was that for things like plant protection products, the GHS or CLP rules tend to underpredict the hazards, which is maybe not surprising, because with a plant protection product, you are formulating things to sort of penetrate and be taken up into systems, and therefore you may have a greater degree of hazard. Whereas on the side of detergents and cleaning products, that if you just based on, did your calculations using the standard methods, you tended to over-predict the hazards of the mixture compared to test data and compared to sort of, practical experience looking at sort of, the outcomes from poison center data and so on. So it has its advantages, but it also it's a very simple system. It's quite easy to manipulate the software to give you a classification that you like, but also it doesn't take into account some of the more complex interactions that people need to think about. So in summary, then, say it's a useful tool for making simple assessments. So it's hazard, not risk-based. It doesn't take into consideration if you've got small quantities, or maybe if you've got something which was a hazardous by inhalation powder that you've now made into a paste, for example, and reduced the inhalation hazard, it still really looks only at intrinsic hazard. Limitations are based on the quality of the data that goes into the calculations, and then the problem of identifying when those simple calculations don't apply, and actually a bit more expertise is needed to judge whether or not you're getting an accurate classification for your mixture. And then finally, we have issues around different implementations of the GHS in different jurisdictions that can lead to different outcomes in terms of classification. So something that may be hazardous in one jurisdiction is not hazardous in another jurisdiction, and that's very difficult for manufacturers, formulators, and so on to cope with. Okay, thank you.
I had to unmute myself. Thank you, Jill. Really, really comprehensive, even though there's so much more to this classification rule. Very thorough overview. So thank you for that. Are there clarifying questions for Jill? I know we see one comment from Linda Birnbaum in the chat. I don't know if you can address this because it's specifically about endocrine disrupting chemicals, and like perhaps the assumption that the EU is using, that it's can be assessed based on threshold effects. I know it fell in that threshold box of your slide. I don't know if you can say anything about this. This might speak beyond what you know. You say this is actually controversial at this point, that the EU is moving forward.
But I mean, we have the same issue with things like carcinogens as well. Some are have thresholds. Some there's a threshold approach is not appropriate, but they're covered in exactly the same way in the GHS. There is a threshold at which you take them into consideration. So I guess it's difficult. There have to be some rules that allow the majority of mixtures to be calculated, but this is where we kind of need a bit more expertise really to judge when, in some cases those rules may be appropriate, and some cases we may need to deviate from them, and that's one of the weaknesses of the system, and just having these sort of standardized rules.
Right, everything's rule based. Right. Other questions for clarifying questions about the GHS classification rule for mixtures before we move on to our last formative talk? I'm curious to know how many people in the audience are actually using these rules, but we can get into that during discussion. All right. Well, Jill, thank you so much. And if we can get Andrew up and ready to share your slides.
There we go. All right. Just going to start my clock real quick. We're going to cover a lot of material today, so we're going to kind of rush. All right. Well, thanks for the introduction. I'm Andrew Easton, representing a group from the Defense Centers for Public Health, Toxicology group, and kind of the example that I'll be working through is our toxicology assessment of per and polyfluoroalkyl substances free firefighting foam products. Traditionally, I don't have to mention my disclaimer slide, but on this one, there's a lot of attention on PFAS-free firefighting foams. They're new in the mil-spec qualification. So as I'm going through the slides today, just remember, I'm the biologist, I'm the analyst, I'm not actually the decision maker. And then the other thing is about the slides I've generated today. They're largely about the technical details. I've consolidated a handful of presentations I've given where I'm really getting into the weeds. But obviously the goal of the presentation today is to really hit the high points. So we're going to fly, across the Himalayas. So you're going to see some valleys here and there. And my notes kind of go down into the weeds, but we're going to skip over them hopefully. So the goal is to use the firefighting foams as an example. And so the overarching motivation of our system for toxicology assessment is really the motivation of trying to do it faster and earlier in the Department of Defense acquisition process, right? The idea is, let's talk about toxicological hazards at the same time as we talk about, for instance, performance considerations or costs, so that we don't have to worry so much about such expensive cleanup. The problem that emerges is really you end up sometimes in a situation with limited data or dynamic data. The data are changing. So this creates sort of this trying to make a decision with nothing to stand on. So we have this kind of push and pull. So the firefighting foams are quite useful because a lot of them are new. And for those of you that aren't familiar, a real quick introduction, aqueous film forming foams, they are products that were used not only just within the DoD, but all sorts of firefighting situations. They contain PFAS, right? So this is kind of the classic forever chemicals in the news. And those are one chemical that was inside these products. The products, however, contain many other ingredients, right? They're mostly water, surfactants, variety of solvents, right? Emulsifiers keep the PFAS in solution. The new alternative, they've been termed fluorine-free foams. They contain much of the same construction as a product, right? Mostly water, some surfactants, solvents to stabilize the mixture. And the idea, of course, is that PFAS were the motivating hazard, right? So the hypothesis, right, you've got this example of a military site where there would be some application of AFFF and the PFAS are going to migrate. The running thought was, well, if we made a product that was less persistent, we'd be able to trap sort of this impact to smaller places. And that all sounds really good. And this leads into what we do in some of our toxicity assessments, right? We start by developing what we call a hazard framework. And again, Gill kind of hinted at a risk-based sense of hazard. And this is, again, we try to include a flavor of exposure, right? It's not an exposure assessment. It's not a risk assessment, but we try to include a flavor of exposure because it's really critical given the scenario of the product. Like in this case, on the far right, the very dilute downstream concentrations, that's a critical consideration for PFAS because that's how they're spreading through the environment. But if these products are truly less persistent, well, that should hopefully help us differentiate the products, whether they show up there or not. And the other thing to point out here, right, we are a One Health group, right? So we consider occupational and human health as equal as environmental health. So that's a really critical observation. Downside to that, or maybe the upside, is it requires a lot of data, right? So it gives us a lot of things to think about and work on about categorizing the data based on whether it's, for instance, mostly environment or some sort of mix and match with mammalian toxicity. But we're trying to assess a whole bunch of effects. As such, we require a lot of data. Now, in this case, the really important consideration is that, you know, the sources of the data vary widely. And as I mentioned at the beginning, if you're in a situation where you have dynamic data, right, maybe we only have a safety data sheet because it's too early in the game and we're trying to be proactive and it's not yet been sort of solidified that we're going to get a full disclosure. So the accuracy of the information that's in the safety data sheet may be up to debate. It's also driven by OSHA regulations, right? So these are maybe different sources of information. So our strategy is to then just gather as much as we can. We have a handful of modeling tools that we use, a lot of EPA products, handful of OECD, also some in-house things with different subject matter expert skills. We spend a lot of time looking at databases, academic literature, and then of course accumulating any test data we can. And then of course this brings back to the prior discussion about how much of this information can we get that speaks to the product, right? Obviously it's very difficult to get testing data for a whole product. And obviously this is where we started working on, because my lab, that's also what we've been doing, right? So anyways, the goal is to try to accumulate as much data as we can and drive towards getting product level data. Then what do we do with that data, right? So we've been discussing GHS categorizations. We've been actually had some EPA discussions earlier here. And so there's all of these sources of information about taking a toxicology endpoint, right? So some sort of discrete scale like an irritation assay or a persistent half-life value, right? Our goal is to take as many of those pieces of information as we can and get them to whatever that system's assignment of low, medium, and high is, right? We're trying to get to what we call a stoplight matrix. Again, we're trying to express information to a decision maker that probably has no idea what an LC50 is or what half-life means. And then the really critical observation is how this actually happens, right? Because again, it's iterative and it ends up being sort of circular because we're always trying to, okay, let's accumulate the best data we can given the scenario we're concerned about in our hazard framework. Let's assign it to some categorization scheme from a variety of those schemes. And then let's review, like, related back to, for instance, the hazard framework is a really critical one. Is this concentration where the hazard emerges even reasonable given what we think the usage is going to be? So we're kind of driving towards that risk-based sense of hazard. And this is just another sort of expression of the process overall. And so we start by building these substance toxicity profiles. That's basically our first approach to see how much information we can accumulate about the different constituents and get a sense of how it speaks to the product. and then move forward accumulating information based on our assessment of whether we actually need more information to make a comparison at the product level. If we've identified that one specific piece of information really helps us differentiate products, maybe we don't need to drive any further. And so I'm going to skip that one. So in the actual work that we're doing on some of these PFAS-free firefighting foams, we've actually published a handful of work of sort of the interpretation based upon information that can be accumulated in a shorter period of time. Within our hazard framework, right, we're concerned about, for instance, firefighters that would be exposed throughout the entire span of their career. So ongoing right now, we have long-term exposures in mice with reproductive and developmental screenings. But we've been able to actually get to a point of making some comparisons, which has been pretty useful. And kind of just to, give the answer up front, and then we'll get into the details here as we move along. Right, this is one of the main takeaway figures from some of these assessments. And again, from here on out, all the slides are super technical, but we're not going to talk a lot about the technical details. So the takeaway message here at the big picture is, the hypothesis was that we should be able to differentiate PFAS-free firefighting foams from PFAS-containing AFFF products, right? Those yellow branches in the dendrogram indicate that these 5 products on the end of those branches are in fact quite similar on their hazard profile. Now, the Buckeye, which is on the green branch, that is the PFAS-containing AFFF product. Because its branch is a different color, we are in fact differentiating it. And so then the question becomes, okay, we've got these 5 that are in fact different. What then makes them different? How do we rank their hazard, right? So you can see, the idea is basically to create this sort of scaling by products and drive towards the similarities and differences. Now that's sort of the simple figure. This is the more complex figure, and in the design is to be simple, right? You can see, oh, I've got some bands of red, I've got some greens, yellows, reds. I can actually pick up the patterns, right, just by eye. But then you start noticing, oh, there's circles, triangles, right? And so this is where we started to run into problems, right? This is where the data were dynamic. We didn't have product level data. There's a lot of variability and uncertainty. And so I'm going to kind of walk through how we worked on these. So as is probably becoming obvious, I'm kind of a stats person and a numbers thing. And one of the main things that we struggle with is communicating the difference between variability and uncertainty, right? For instance, surfactants, sodium dodecyl sulfate, right? Hundreds of data points, right? So it's kind of framed as an uncertainty about, well, which one should we pick as the representative tox value? And of course, my point is that's variability. And so down on the bottom right, I start to think about all of these decisions as, do we need to make a protective choice, or do we have some sort of context from our hazard framework that would maybe change our description of the categorization, right? And here as an example, I've got these green triangles and orange triangles. The green was actual test data that we did with the whole product in-house at a 3% mix, because that's what a firefighter would actually get on their skin most likely. Well, then it's low hazard. The orange was what we got from the SDS or the constituent-based, sort of most hazardous and sort of the protective choice. So if I provide you with both and you're a decision maker and you've got a good context of why these are different, you can work with that choice. Now, uncertainty is where things really start to get interesting with trying to speak to a product based on information from constituents. And again, we'll kind of skip over all of my notes here and look at the bottom right corner, right? Here's a situation where we've got circles in the matrix. The idea here is we had to accept a constituent piece of toxicity data to speak to the product, because our main goal is, let's just fill the gap. Can we fill the gap with something so that we don't have NAs or sort of, complete unknowns? And in this case, we took the most hazardous constituent and just plugged it in and accepted it as speaking for the product. However, we did qualify it by working through what we called a assurance score. So that assurance score is built on a data quality score. So we wanted to give a decision maker a sense of, well, do I trust my own analysis, right? Can I assure you that you'll make a good decision based on the data that's available, right? So completeness, were we able to identify some sort of data about a specific endpoint? And then a proportion, right? So a number between 0 and 1 on the rate of how much that information spoke to the product, and how much of it came from an actual empirical experimental data source, not just a read across model or some sort of other mathematical model. And then based on, again, our hazard framework of speaking about products and having limited data, we're early in the game, the decision was made to weight that. So we're going to multiply it by the percent that was disclosed, and in this case, as a proportion on the SDS, because at the time, that was all the information we had, and it was the biggest concern, because some of these products were, listing, as low as something like 15%. So it became very difficult to, sort of provide a sense of the, in essence, my assurance that you could make a good decision from the data I've presented. And then kind of the takeaway really is about making and breaking ties. If you're looking at the hazard profile, which is kind of the horizontal rows in the stoplight chart, you can see some of these data assurance scores are very low and some of them are very high. If you've got similar hazard profiles, but different data assurance scores, you maybe should consider those hazard profiles different. If you've got different hazard profiles, but very different assurance scores, maybe you would drive them a little bit closer. And that helps with the decision making, basically. In the sense of products A versus B, maybe they should be more or less different. And then I'm going to kind of close by talking about ToxPi a little bit. And again, because I'm trying to not have so much math in this conversation, the goal is, all right, so we've got all these color schemes, and those color schemes can be boiled down to numbers, and then we can cluster those numbers and we can create one score for a product. And the end result looks something along these lines, where instead of that whole matrix for essentially one row of that matrix for one product, we've got 4 triangles, right? We've got 4 characteristics. This is in fact called a radar plot. It's not actually a pie chart. So don't consider the angle, consider just the size of the pie slices. And in this case, pie is good. I want more pie. So bigger is better. And so we can look at this profile, right? We've got 3 pie slices and we're missing this purple slice. The sort of idealized one is in the bottom right corner. And so this tells us that this product, relative to the other products that are in the assessment, is one of the worst in this certain characteristic. Then you can take the mean of these scores and get one number, right? So the idea here is then we can have one number to represent the product. We can have one relatively simple expression of the profile per product. And then we have this matrix where there's a vast amount of information, a sense of our uncertainty, and the whole kind of closing message then becomes you can make a decision at several levels, all of which are driving towards speaking about the product. And so again, summary, speaking about merits and challenges, right? So the specific text in these slides are actually about the tox assessment of the products, but for today's purposes, right? Vetting against a similar hazard framework, right? The goal is to have this kind of harmonized sense of how we're going to compare products against one another given toxicity data. But because we're still interested in maintaining this hazard framework, one of the challenges becomes then it's not harmonized, right? And then kind of the same thing goes if you're in these dynamic data situations where we're accumulating information over time, it becomes difficult to harmonize if the information that you're gaining is going to increase over time or maybe decrease depending upon the scenario. Let's see, what were my other notes about this, right? So, and again, it's about being targeted, right? So like in this case, the concerns were largely about persistence, right? And as hypothesized, we see the data agrees that it would largely be reduced. But again, that's driven by the framework that's established in the beginning. So whatever chemical or products are coming down the pipe next, we're going to have a sense of reevaluating that hazard framework again to make sure that we stay targeted. And then lastly, in closing, about talking about the quantification of uncertainty, this is just really critical, especially because we're trying to drive towards product level interpretation, but we're fully aware that we're not going to have product level data unless someone is doing testing at the product level, which is in fact rare. All right, and so I'm going to close by just acknowledging a handful of co-authors. Lindsay Holden, she and I developed some of the first drafts of these efforts for the PFAS-free products, and Valerie Adams specifically worked on sort of designing this concept as a product or as a process about trying to incorporate toxicological hazards early on in the Department of Defense acquisition and how we move towards talking about product specific data instead of chemical specific data. And so with that, back to you, Molly.
Fantastic. So stay with us for just a minute. Questions for Andrew, clarifying questions. No, I have one, Andrew. I mean, one thing that I felt, I don't know, illustrative maybe about this program and project was the fact that in some cases you all did have product level testing data for some endpoints. And I'm just wondering how, like, can you speak a little bit more about how that was integrated into the assessment, maybe how those endpoints looked when you actually did test the product versus what an with an SDS or what the literature was telling you in general about, endpoints that you should suspect?
Yeah, here, sorry, I shouldn't have stopped sharing my screen. Yeah, this is a really important consideration. So, sort of on the large scale, right? And so this matrix here is pretty complicated, but it does give us, these are actually 7 PFAS-free alternative products, and then the AFFF down on the bottom that contains PFAS, right? So for instance, the repeat dose oral toxicity column, right? So it's kind of, it's a human health one, it's a mammalian one, so it speaks a little bit to wildlife, right? Early on in the process, before we had actually in my lab done 28-day exposures in mice with the full products, this column would have all been circles, and they largely would have been based on the surfactant toxicity. And some of the surfactants were going to be essentially reds, yellows, right? So these would be sort of indications of high, medium, moderate hazards based on protective assumptions about the individual constituents. As a toxicologist, we attribute this largely to dilution because you're getting exposed to the whole product, so you don't have so much activity. And in this case, the mode of action of surfactants would be driven by irritation. But that column goes from being very sort of low confidence to very high confidence. And in this case, relatively low hazards, except for some of the singular products, right? So we're able to extract one from the list based on actual whole product testing. So, and there's other areas, right? So a lot of the aquatic testing data, that data emerged from other collaborators from the CERTIP program. And then, of course, obviously right now my lab is working on the reproductive and developmental screening. So eventually we'll have squares in there. And then the skin corrosion and irritation testing, a lot of those triangles were just a full orange square because the only data we had was from the SDS that said the product would be an irritant. But we did testing in a in vitro assay at 3% dilution to just kind of limit the logistical constraints. And so now we have this sort of 2 factors to compare there. So that's a kind of a long-winded answer than you probably wanted, but it has significant changes when you can actually accumulate this data. And that becomes, I think, the challenge is just how long does it take to accumulate that data, and is waiting worth it, in essence, if you're really thinking about at an organization or a policy decision.
Yeah. So Rebecca O'Donnell has a question, and I know this speaks beyond your expertise as a toxicologist, but it's a question about the effectiveness of the the PFAS-free foams. I know, Andrew, you mentioned the CERTIP program. So under DOD it's called Strategic Environmental
Research and
Development Program. Has done a lot of work evaluating performance of a lot of the alternatives, and now they're officially being evaluated under the performance specification for these foam products by DoD. And I don't know if you just want to mention how that is unfolding.
Yeah, so the first thing to state is I work in a toxicology directorate, and so our goal is, I think actually Gill alluded to it in the GHS categorization. If you've got some sort of subject matter expert that is just pulling toxicity data, maybe their interpretation isn't exactly an expert one, not exactly the best. So our method that I've described here is about the incorporation of the toxicity data in the acquisition process at large, not at the very end after the performance has already been evaluated and after, sort of the official SDS and product labeling and costing and all these developments have happened. Let's do the toxicity work up front. And then we'll talk about performance of the alternative. So that is actually happening right now. So what actually happens in the mil-spec qualification process is there's the list of qualifications released by the Department of Defense. When companies want to submit a product, their directive is essentially to submit a packet with all of the data and evidence to support the decisions around that mil-spec, including here is a sample, this is a fire testing lab, go evaluate the performance. So in that case, that ended up actually being, it's a challenge to then reevaluate toxicity data based on the fact that a chemist or an engineer can change the formulation for performance characteristics probably much faster than they can given toxicology situations. Maybe they don't know about the EPA Safer Choice website. But anyways, there are ways to work on that. And we're going to continue to evaluate that. But in essence, performance is considered. It's just not something that I'm doing necessarily.
Yeah. It's a large group that's doing these
Yes.
acquisition processes. And Moha put into the chat the list of qualified products that are actually publicly available in a database maintained by the Department of Defense. And so you can see which of these alternatives in fact meet these performance and environmental performance requirements under the mil-spec. So any other questions? Yeah,
I will point out too about that, just one last little thing about the qualification, right? Because of the NDA timeline, right? It is fully expected that as more F3s come online and, we can essentially have more conversations with peers like this meeting about the alternatives assessment and talking about the toxicity. There's more data going to come out. I would encourage you to expect the mil-spec and the qualification list to change as we move forward in the future.
Yeah. I've anticipating the same. Yes, so the NDAs, Congress has mandated that the Department of Defense identify alternatives, and move forward with them by October 1st of this year. So you're going to see, those being listed very, very soon. Again, other questions before we just move and open up our discussion together? Well, with that, Andrew, if you don't mind putting down your slide, I'm just going to put up a little bit of a deck here myself, and just move us towards discussion. One thing that as I mentioned in the beginning, we really want to hear your perspective. And enter more voices into this conversation. So don't feel just obligated to use the chat. We're interested in your insights and having this feel more communal. So please do raise your hand and feel free to unmute your line and turn on your video. And again, feel free to use the chat. I'm going to be monitoring hands. My colleague Kathy is going to be monitoring the chat. So hopefully we'll get some interesting discussion going. I can't seem to move this. Hold on a second. So one thing that I just want to start out on, and I really appreciate both of our, at least our first conversation with Lauren and our presentation with Lauren and also Andrew. I think they really emphasized, we're evaluating mixtures, but we're making decisions about them, right? We're making decisions to give them a certification. We're making decisions to qualify them for procurement. And so that is kind of a unique context in terms of how we're thinking about evaluating and utilizing the research on mixtures. And so I just want to just open it up to all of you. I'm just interested to hear, what are your drivers and needs for making decisions about chemicals and formulated products? If let's just add some context for your decision, context around this question of the evaluation of mixtures in formulated products. What are you wrestling with? What's the decisions that have to be, that you're needing to make? And I want to hear this because I want this to frame our discussion together going forward. I just want all of us to hold this context as we think about merits and challenges and opportunities going forward with the methods that we currently have. Anyone want to? Andrew, want to add some?
Yeah, I'll offer to raise my hand. If there's anyone else that wants to speak
Yeah,
from the
please
audience,
do.
I know you're trying to specifically solicit, so let's maybe wait a second and then come back to me, but
Okay.
I'm definitely willing to answer.
I might call on people in the audience too, if you all don't.
Well, we actually have a comment or a question in the chat.
Perfect. Thanks, Kathy.
So this is from Taryn O'Connor, and she's asking how to do a toxicity testing without doing animal testing to keep Leaping Bunny certification. And I think that would be open to the audience, the wider audience, I think, as well, if they have insights to that.
I mean, I'm happy to offer at least EPA's perspective if that's helpful.
Yeah, please. Thanks, Lauren.
Yeah, so, there are new approach methodologies for certain endpoints, acknowledging that they haven't been developed for all endpoints, but you can typically, do some sort of in vitro testing to at least answer a question about hopefully, whatever the criteria is or whatever hypothesis you are testing. So I know that there's been a lot of progress in this area. Even recently, the OECD has come out with like a Gill fish line study to get around aquatic testing. So there's a lot of progress, and we're still making more progress, but I do acknowledge there are some limitations for certain endpoints.
Thank you. Hopefully that was helpful, Taryn. And yeah, Moha added a link to some of the NAMS work coming out of EPA.
And we have another comment in the chat from Lynn. Key drivers, global regulations, sometimes aligned and sometimes varying, is challenging for customers with a global footprint market, but more importantly, customers drive towards upholding duty of care.
Lynn, do you mind just explaining more what you mean by the duty of care? Feel free to unmute your line.
Molly, can you hear me?
Yeah.
Okay. Okay,
Yeah.
thank you. Good morning, everyone. So it's more of a lot of our customers, they are concerned about the PFAS regulations that are coming out in all areas, right? Like whether it's in the EU, Japan, the US, Canada. And quite often for them, it's not necessarily being compliant. What's driving them now is this duty of care. How can they get ahead of this? And this is why, to your question, what are those drivers' needs for making decisions about chemicals and formulated products? That's where their driver is. We're a SaaS platform provider. And so this is where we're working with our customers to identify or provide them solutions that will help them in this decision-making process. How do we help them understand what the risks are? And thank you, to all the speakers today, Lauren, Gill, and Andrew, for sharing your insights and the work that you're all doing. Because again, it's a matter of, not everybody, unfortunately, is experts like these three speakers. Not everybody is a toxicologist. Not everybody is a chemist or a biologist. So quite often for them, at the end of the day, it's helping their organization uphold that duty of care. And how can they do that? What's the best way? So that's what I was trying to offer in terms of my comment.
Great, thank you. Yeah, so, hearing regulations are key drivers, procurement is a key driver, certifications are a driver, for making decisions, and the processes we're using to evaluate formulated products. Anything else before I just kind of move on to another question, just to get us all talking together?
Hi, Molly.
Yeah, please.
Oh, I'm sorry. This is Martin.
Hi, Martin.
There's
Thanks.
customer expectations over the past, I'll say, half century. There have been repeated experiences by the consumer of finding that ingredients in their products can be harmful. And this has created a mistrust in companies that sell these products, and industry generally, and I'll say seventh generation specifically, is trying to overcome that lack of trust by making commitments as to what ingredients will be used in their products and what the risk of harm from those products is. And it should be pointed out that what a consumer considers safe is not necessarily the same as what a regulator considers safe, is not necessarily the same as what a product formulator considers safe. And this drives us to select ingredients that have a low hazard profile so that we can make statements about what is and is not in our products, and hope that those statements comport with consumer expectations regarding the safety of that product. So it's driven by our consumers.
Interesting. Interesting. Thank you. Any last perspective? And I should ask all of you, to introduce yourself and your organization. Martin, of course, many of you know us from seventh generation, but helpful to maybe recognize your organization as that kind of is influential of some of the perspectives and comments that you're providing. Other thoughts? Well, one thing that I'm interested in, we heard essentially 3 methods. There was some consistency across all of them. But, interested to know, how you, just your thoughts. We heard from each of the presenters about some of the merits and challenges of these methodologies. Interested in your perspective. Also interested in maybe adding a couple other approaches to the conversation. We selected 3. There's many other approaches out there. But I want to just open the floor. So, what are other methods that people are using? And also, what are the merits and challenges that you're seeing with these methods? What's working? What needs to evolve? And so I'm just going to open it up for conversation.
Molly, I have a comment just to get us started. First of all, thanks again for all the great presentations. And what I thought was really interesting, particularly with Gill's presentation about GHS mixtures, is something that I've come across recently, is just this idea that the GHS mixture approach, particularly as it's embedded in the sort of SDS disclosures and that kind of level of communication, that level of information is sufficient in all of these decision-making regards. And I think Gill did a good job of highlighting the challenges with that, with those approaches. And I would definitely say that's one of the challenges I've seen, is that folks that are not as familiar with the alternative assessment field, or say, engaged in the safer chemicals approaches that, I think a lot of us are already familiar with, Safer Choice, other certifications like Cradle to Cradle, et cetera, are those assessments go to a much higher granularity, whereas as shown by Lauren, that all of the ingredients, even residuals, are evaluated and considered in decision making, whereas in GHS, the mixture rules suggest that after a certain threshold, which could be quite high depending on the level of character classification and what the endpoint is, that information doesn't even get disclosed in this level of communication. So I think it's just maybe the challenge is just acknowledging that although SDS approaches and disclosures are really helpful, with regards to the level of information that's needed to really make high quality decisions for safer chemicals, there's generally a higher bar that needs to be met.
Yeah, thank you for that. So something that you just mentioned, just the threshold, and also just comparing approaches. Lauren, I'm also just struck by the safer choice approach, which kind of allows different thresholds depending on the functional use. I'm just wondering if we can dive into that a little bit more about how, because you mentioned, if in fact there's, you might have one hazard profile that's accepted for a certain functional use that wouldn't be accepted, or that is accepted for another. And is that based on, what else is that based on, that you can see that difference? Is it kind of these are all intrinsic hazard evaluations, so you're not assuming anything about kind of conditions of use, or are you, when you're making that functional use evaluation?
Very good point, Molly. So one quick clarification is the thresholds are all the same for endpoints. It's just a matter
they're all
of
based on like the GHS and the new chemicals thresholds.
Right. But you're right. There are some endpoints that we're more focused on than others, depending on the functional use. So a great example is surfactants. Right now, our criteria focuses mostly on environmental toxicity and fate, because surfactants are known to be aquatically toxic for the most part. And, we can differentiate based on degradation. But let's say that a surfactant could serve a different purpose within a formulation. If that functional use, the other functional use it's using is one where we typically include human health endpoints, right? Then it becomes challenging, especially if we're going to list on skill. So it might be listed as, a surfactant on skill, but then if someone wants to use it in a different way and we don't have information supporting that it meets that criteria, it becomes really challenging. And it's also very difficult to communicate that to a partner, because they see it on skill, right? And they don't understand why that won't work. So I think in developing the safer choice standard and criteria, to your point, the conditions of use was established up front, that most of these are cleaning type products. The exposure pathways are fairly similar. Obviously we do more than just cleaning, but they are all relatively similar. There's no ingestion, there's, things like that. So that was taken into account when we established the thresholds. And then truly it just came down to looking at the class of chemicals within a given functionality, like surfactants, and knowing, okay, these endpoints are typically where we need to focus to figure out which ones are in fact safer or not. Does that get to your question?
Helpful. Yeah, and hopefully it helps others as well. Yeah, thank you. Other thoughts about this question of, again, when you look at it across these three methodologies, and please others chime in, what are some additional attributes or methods you're using in your evaluations? Anything unique that was perhaps different than what you've what we've described right now?
Just to note, before we not to jump in and divert the conversation again, but Moha did post another comment in the chat about publication on leveraging data by different disciplines to limit regrettable substitutions. And there's a link provided there. And also Karen noted in the chat that challenges equals availability and robustness of public data, which I think I could definitely attest has always been an issue.
Right, exactly. Yeah, we heard that across the board. Moha, if you don't mind if I put you on the spot, because I know you've done work in this space on mixtures, what's your reflections on some of these merits and challenges, and also some of the opportunities you see going forward with new approaches?
Okay, yeah, thanks, Molly. I have been posting in the background.
Since you're involved and active, I thought I'd call you out here.
Yeah, no worries. We are actively working on the mixture. As you know, it's just we have a partnership with the Navy for some version of the formulations that they have.
So these are the firefighting foam formulations?
Yeah. Why I'm saying this, because there has been different iterations on the formulation along the past year until they finalize it for final publication. And I mean, as an environmentalist, there is a hypothesis that I keep hearing that, yeah, any alteration in the formulation shouldn't affect the toxicity much. And then I just stop the speaker and say, like, let's pause here and just like, is there any basis for that? You change the background constituents, and there cannot be that blanket statement that, okay, you changed that a little bit and it should be the same. Mixtures are tricky, mixtures are weird, and that's why what we are attempting to do is just like going all over the place. We have the same formulation split among so many different labs, targeting different toxicity endpoints, from like gene expression all the way to like behavioral and developmental and different species, some cell-based or mammalian cell-based toxicity. So our target is to put that together side by side and see what kind of red flags that came from that, what kind of lesson or that we can take notes from it, what is reproducible, what is not, that kind of thing. So there is a lot of unknowns, and since this is a good time to have such discussion, I call it as the next big snowball. Like, we are in a seeding phase now with just like actually it's only one that I put the link for it now, that it is being published. But moving forward, you would see different formulations with different chemistries and everything. So together, I guess, like maybe at some point join forces with Andrew, we compare notes, because I can see a lot of overlapping activities. But it is good like to have these like siloed activities, but we know that we both exist, and we can communicate at some point and compare notes and see where things can complement each other. So this is where we are. We are still collecting data. There is no conclusion whatsoever, but hopefully by early next year, we would have compiled all the data from different groups, and we have a clearer image, at least for the limited number of formulation that we are targeting. We have like 2 fluorine-free foam and the Buckeye as like a benchmark of PFAS containing foams. So yeah, this is what we have. Challenges, it's just trying to convince people to give us data on a timely fashion, and that's has been the main challenge for me. But everyone is excited. Everyone is so far very collaborative. But how can we just make it a sustainable work plan moving forward? I guess this is what I will need to think about it more. My plan for next year is actually like first year of the project, it was 2023, focused mainly on toxicity. 2024, the plan is actually to going very, very hardcore testing in the biodegradability aspect. There is some data, but there is also the very big blanket statement of, yeah, these are just a bunch of surfactant, you should expect it to biodegrade. And then I'm not really convinced about that, because what we see from the replacement formulation, they are very, very, very highly acutely toxic. We need to dilute this formulation to infinite dilution in order to get like no mortality, and to see like some of the chronic testing that we are attempting to do. You would see like dropping a microliter in diluting that so that the organisms wouldn't die. So I think that requires different way of thinking. Just like there is no silver bullet that we should expect. So yeah, this is where we are so far. I'll stop and pause here.
Wow, super interesting. I think you said a lot of things that might pique folks' interest. Yeah, just if we did do product level testing, what's the concentration you need to test this out? I mean, what you're seeing is, it matters. Sherry, did you have some insights and thoughts? And I know maybe you want to invoke some methods that are coming out of green screen that might add to this discussion as well.
Sherry, you're muted.
You might want to unmute your line. It looks like you're on the phone, so if that's the case, do star 6.
I was muted. Sorry. Can you hear me?
Okay. Yep, we can. Thank you.
Might be able to even be more able. Can you hear me better now?
Perfect. Yes, much better clarity.
Okay, great. I was saying, I was just going to speak a little bit to the question you had up on the screen here about the merits and challenges of alternatives assessment regarding the methods presented. And I think there were two things that really stand out to me. One is data availability and lack of data and how huge that can be. So for those of you who don't know me, Sherry Franjevic, I'm the Green Screen Program Manager at Clean Production Action, and we have a product certification program as well as a chemical hazard assessment methodology called Green Screen for safer chemicals. So anyway, in the context of mixtures, in the context of products and safer products, I think that, you know, what data you're looking at really, really matters. And so if you're, you know, taking just the data that's presented on a safety data sheet versus actually looking at full formulation data, you're going to get different answers. And oftentimes the most toxic ingredients are there at low levels. And that really matters not only for the use phase of the product, but if you really think about the life cycle and that somewhere along that whole supply chain, particularly in production as well as end of life, you're going to get these big exposures that have major environmental justice ramifications. So I think that's something important to think about for the low concentration ingredients, that it isn't just the use phase of the product, but really thinking about the entire life cycle. And the other thing that really stands out to me is that how you prioritize the different endpoints, which I think is incredibly complicated. And, you know, this is no small feat to decide, well, does it matter if it's potentially carcinogenic, or do I care more that it's a skin irritant, but it's used in this way? But, you know, so I think there's all these different, you know, when we're talking about toxicity, it's not just a single endpoint like water use or energy use. This is like all these different endpoints from all these different tropic levels and all these different types of organisms, et cetera. And so making decisions with that level of complexity is incredibly challenging. And so what you're going to see is that if you prioritize these endpoints differently, you're going to come to a different conclusion, right? So on top of the mixture question and, you know, are there synergistic effects or what's really happening in the use phase, there's also the life cycle considerations and the prioritization of, you know, what's the worst bad. So just wanted to add those pieces to the conversation.
Thank you, Sherry. Thank you. Others, I'm not seeing any hands raised. I don't know if we have any thoughts in the chat.
No, we're quiet in the chat.
Maybe I can turn to my planning committee here that has been helping to think this through after hearing these presentations. Like, you know, what stands out to you? Seeing a hand, Lauren. Thank you.
Hi, Molly. This has been a really great webinar. Thanks. I have a question about something that, well, I think all the speakers addressed, is that product testing data are rare. And I'm questioning to what extent they're even desirable. And this sort of touches on something Martin said too. It seems to me that there are certain endpoints that are very conducive to product level testing, like irritation, corrosion, flammability, things like that. But other endpoints, at least from the consumer side, you wouldn't want to dilute the level of a carcinogen and say it's fine, right? Because I don't think consumers are happy if there's any really reasonable level of carcinogens in a product, right? So is there an argument that only certain endpoints should be tested at the product level, or do you think all levels, or there's value in all endpoints being tested at the product level? And I was thinking also, you know, that would drive a lot of animal testing, but maybe there's value in product testing using in vitro tests. I don't know, for all endpoints. So I have a question really about those threshold endpoints versus the ones that are more conducive to product testing, and if the speakers agree that there's really a limited set of endpoints that are best tested at the product level.
That's great. Anyone want to respond to Lauren's comment And I want to open it up also, folks that are actual product manufacturers, are you doing any of these like product level tests? How do you think about product level tests, or is it just not the norm? And if you did do it, what kind of endpoints would you address? But yeah, anyone want to take Lauren's question? And Andrew, Gill, I'm not sure if you have, come online and tell me if you want to respond.
I was gonna sort of comment on that. I kind of combining actually the last couple topics are kind of important to me. The idea that some of these proactive approaches are customer driven. I mean, that's the regulatory structures are not necessarily designed to be proactive, right? And different I'll say municipalities have different approaches to this, of course, too. But some of that means then you're operating in a data poor environment. So there's a little bit of feedback there, but then it does drive to what I think is a really good and important question about prioritization of your endpoints, right? Our approach was to say, look, here's everything. It's all relatively equal. Nothing's weighted. We're just going to put it in 4 different bins based on, environment versus human, right? These are really generic. And then we're going to strive to get as much product level data as we can. But in hindsight, right, the result ended up being comparisons, right? And so if you have a whole bunch of this product is equal to this product is equal to this product, is that really an alternatives assessment, right? Did we really gain by doing that? And then maybe it is better, right? Again, let's do whole product testing in the in vitro settings, because that actually helped us differentiate the products,
Right.
and maybe that's more influential. But then you come full circle and you're back to thinking about what the public's interest, says, get bad ingredients out of products. You know what I mean? And then it just becomes this kind of circle. So anyways, I think that those are issues that we've wrestled with, and I think a lot of people are working on them, and I just think that they're really critical observations. But I wanted to point out that I just feel like they're very linked, and they will change over time, right? Are we talking about firefighting foams, or are we talking about some completely different product, right? So anyways, I think it's really, I'm glad that other people are thinking the same. These are problems that are interrelated. It's
yeah, no, they absolutely are. Gill, do you have some thoughts?
Yeah, I was just going to say that in the GHS, you aren't allowed to test your way out of certain classifications that are based on ingredients. So carcinogens, mutagens, reproductive toxins. You're not allowed to test your way out of classification for those. So it kind of is addressed a little bit in the system already. So there wouldn't be any point in doing product level testing unless you were trying to demonstrate an effect that wasn't otherwise identified from the ingredients.
That's interesting. So it almost prioritizes the ingredient level assessment over any data coming out of a product level assessment or testing specifically.
Yeah,
Interesting. Lynn.
Hi, my name is Lynn Nakayama-Wong, California Department of Toxic Substances Control, and on the planning committee with Molly. So as a regulator who has to make decisions on whether a product is safer based off of a manufacturer submitted alternatives analysis, thus far, right? Like we have not seen, we really aren't seeing product level data, mainly because our regulatory timeframe is so short, right? For the submission of the first preliminary alternatives analysis report. But what I'll note is in terms of prioritization of endpoints in our framework, we actually ask for the responsible entities, the manufacturers, to focus on the endpoints of concern that we as DTSC have highlighted in our prioritization. So I don't think there's necessarily a short list go-to for across the board. It is definitely product specific. But as
I think the expectation, well, no, there is an expectation that after you get past this preliminary screen, that if you get into our stage 2 alternatives analysis process, that it's a more refined, you are looking at all the toxicological endpoints again, because within our framework, I don't want to say all hazard traits are equal, but we are definitely looking at all of them in our prioritization scheme as a department.
Mm-hmm. Thank you. Yeah, interesting. And interesting that the priorities also, vary based on the product, based on, the what's coming out of the program in terms of priorities itself. Other thoughts? Again, just wanting to dig into this question of what's working in these evaluations, or what do we need to improve on going forward? Kathy?
Yeah, if I could just jump in to get this to address on the question that Lauren, or comment that Lauren had about, where do we do product level testing? When is it appropriate? And I think that's something that I've been struggling with, because, being in hazard assessment for almost 20 years, particularly in the context of safer chemical assessments, it's always been very hazard heavy, looking at the ingredients, looking at trying to get full disclosure, using the best available information that you have. And when I hear about evaluating in the context of mixtures and whole product testing, I immediately pause, because I think, oh no, dilution is mitigating potential harmful effects, and it can be very easy to hide potential harmful components by saying, well, the product test is fine. In my mind, this is where I think the OECD minimum criteria is so helpful and powerful, in the sense that we already have sort of a standard, so to speak, or an agreement about what is what is the criteria for safer in general, and we shouldn't be, in my mind, a product shouldn't be formulating with something that is a known carcinogen, for instance, or something that we know is going to meet criteria for high concern. If they're trying to identify this as a potentially safer product compared to what's out there conventionally. So at least I feel like that there's already, at least at the ingredient level, there already is some sort of establishment of a minimum criteria that can be applied. And then I feel like if that's met, then I think it's helpful then to go into these discussions about the impacts at the product level. Are we missing something as the mixture is formulated? Potentially, if there is something more hazardous being formulated as a result, or occurring as a result of this formulation, or perhaps maybe we are being, in certain cases, endpoints, are we being overly conservative in some of these assessments if we're looking at, say, smaller ingredients for, say, an irritating endpoint.
Yeah, I mean, I think it comes down to this question of how do you test the full product? What's the appropriate methodology to test a full product, given that we don't do it routinely? And, there is this outstanding concern of seeing synergistic effects, or seeing effects in general that you don't even see at the ingredient level, right? So it's one of, you ask the question, but we don't know the answer unless you actually pursue it further. But the question like you're raising is, well, what's the right methodology to even do this? Because dilution is not the solution to the answer that we're trying to seek. Well, I'm going to move us just to this last question. And it's really one of, helping us get to this point of where do we need to go from here? Where are there specific needs and opportunities to advance these methods? Are we seeing alignment? And so this question of, especially with the GHS mixture rules, that's an established methodology. It's a go-to methodology. Safer Choice has its go-to methodology. But anyway, thoughts on needs and opportunities that you see, to support product level alternatives assessments, especially examining the hazards going forward. Any need arising based on this conversation? I mean, I'm seeing one. If we did test the full product, what's the methodology for that? Having some standardization of what that needs to look like. Is it based just on the condition of use, or is the fact that with what Moha said, if you put these AFFF or these PFAS-free formulations and tested them at full concentrate, they're going to kill organisms. Is that interesting? Is that useful to know? To me, that's one question coming out of this is, how do you do this going forward if you did test the full product? Again, a question that also Lauren elevated.
Hi, Molly.
Yeah, please, Martin.
I'm jumping in because you don't seem to see my hand. So Martin Wolf, 7th generation. And the only full product testing for safety that we do are irritancy tests where we can use a human volunteer, because we do have the CCIC Leaping Bunny logo and therefore test the whole product on animals. For all of the other toxicities, we use primarily the GHS additive formula and calculated toxicity, be it the LD50 or some other toxicity. But the problem I have with alternatives assessment as we're discussing it is that we are, in essence, looking for an incremental change from a base product. We're trying to make a single substitution. And what we really need to do is step away and say, what is our objective in the performance of this product, but also in the safety of the product. And I think that requires a total rethink of the product and requires constraints on formulation at the beginning of a project. So if you don't want to have chronic toxicities associated with your product, and to Dr. Birnbaum's point, when there are hazards that do not have a defined threshold, you have to begin by saying, I'm not going to use any product that expresses a chronic toxicity, and then formulate a product to meet the performance needs with that constraint in mind. And that way you don't begin with a framework formula that you're trying to adjust to remove a component or reduce an overall toxicity, but you begin with your endpoint hazard assessment in mind and formulate a product to that assessment. So I think the alternatives assessment, and I'll also add, this also opens up your mind to alternatives to chemicals or chemical mixture meeting a need, and allows you to consider mechanical and other means to address that need. So I think rather than think narrowly of single chemical substitutions, we need to think more broadly and bring the assessment to the beginning of the product design process with low hazard as one of the key objectives. Being
the design rule itself. Thank you. And thank you for jumping in, because you're right, I did not see your hand. Well, we're about at time. Does anyone have any last remarks that they'd like to enter into the discussion?
I just put in the chat, like related to Martin's note, like a recent book by Paul Anastas. It's about first do no harm. So it requires a lot of education. This is, I guess, the easiest way to describe it on different levels. But yeah, thanks, Molly, and all the organization team for this workshop. Very, very, very informative.
Thank you, Moha. Yes, thank you to our team in total. Well, what's coming next? So we have our second workshop, and we're going to be digging into just hearing how, the broader research community, and also how, formulated product manufacturers are thinking about this. How are these mixtures questions and evaluating, there's improving upon their safer, evaluating the safety of mixtures. How is that being done in different fields, and how might we transfer that knowledge to this alternatives assessment and substitution context that we've been talking about today. So that's on October 6th. And if you haven't registered for it, we're trying to build this discussion. So join us, and we're going to, enter into the discussion, the knowledge and foundation that we've learned today, and build upon it on the 6th. And again, the third iteration of this is at the International Symposium of Alternatives Assessment. This is an in-person meeting, and I highly encourage all of you to join us in Tacoma, Washington. It's running the 24th to the 26th. This session itself is on the 25th. And again, you could register for both of these events at the saferalternatives.org website. And let's see, lastly, I just want to make a pitch here, because I am wearing my Association for the Advancement of Alternatives Assessment hat in this dialogue, in this workshop today. Join us, become a member of this professional society. It's the only society out there that's trying to advance the science and practice and policy of alternatives assessment and informed substitution. It's a very diverse array of practitioners in government and industry, NGOs, consultants, all trying to advance our transition to safer chemicals, materials, and technologies. So join us. Again, you can become a member on the association's website, saferalternatives.org. And with that, we're going to close. And I hope that you all found this interesting and can join us in the next 2 installments of this workshop. Thank you for your participation. And with that, we'll close us out for the day. So thanks, everyone.